All right, we're going to finish up those problems from Thursday. We did one and did we do 1 and 2? Great, thanks for your input on that. It's nice. Appreciate that. When everybody answer at once. All right, so for number 3, because we didn't get this far, what would we do first?
Multiply by
Put your Chromebooks away. So now that you got your stuff out and we're all done weekending, go Eagles. What's happening with my, oh, okay, good. So what would we do with number 3?
What are we getting rid of?
It doesn't matter. That's why I'm asking you. X's, excellent choice. So we're going to turn them all into 6s. So what do I multiply the top by?
6.
So by 6, by 2, and by 3. Good, good, good. So we're going to wind up with a top of 6x plus 24y, minus 36z equals negative 54. And the middle is going to be negative 6 of those, positive 4 of those, positive 8 of those, and 26 of those. And then the bottom is going to be 6 of those, negative 9 of those, negative 3 of those, and negative 21 of those. Oof. All right, we did it. So we created a eliminatable system here. So when we add them downwards, how many x's do we get? None. Oh, oops, never mind. We're not doing them all right now. Yeah, we'll do row 1 and row 2 first. Right, sorry about that. And we get no x's. How many y's? 28 of those. Minus 28 of those. Yeah, I don't think so. Negative 54 plus 26. If you owe the bank $54 and go deposit 26, you still owe the bank how much? Negative 28. Okay, I see we're off to a ragingly good start on this fine Monday. All right. Now let's add rows 2 and 3. How many x's do we get? 0, right. How many y's do we get? Negative 5 of those. How many z's do we get? Positive 5 of those. And what is our constant term? Good job. That went better than last time. Good. You can already see the relationship, right? But let's make this official. We're going to want to multiply. What can you turn 28s and 5s both into? If you can't answer that question, that's okay. But let me ask you from a different perspective. What would we multiply both equations by? Like what? Yeah. Remember, if you're not sure, just multiply them by each other. So like if you're trying to kill a 5 and a 28, you can just multiply the 28 by the 5 and the 5 by the 28. And that's actually the best you could have done in this case anyways, for the record. So across the top, we wind up with 140 y's minus 140 z's equals negative 140. You could already see the proportional relationship, the 5 to 28 across the board, right? So we're pretty sure this is going to have infinite solutions. It's probably going to wind up being a 0 equals 0 situation. But again, let's verify. Across the bottom, we get negative 140 of those, positive 140 of those, and that equals positive 140. And now we have an eliminatable 2x2 system. And regardless of which one we set out to eliminate, it doesn't matter. They're going to just kind of take care of this for us. So if you add downwards, the y's eliminate and the z's also eliminate. And what do we put when everything eliminates? 0. You need to put the number 0 when everything eliminates, okay? Usually we just leave things to die when they eliminate, but the 0 holds the equation together. And then on the right-hand side, negative 140 plus 140 is, and 0 equals 0. And for that reason, while everything coming together, that means we've established that we've got a couple of equivalent planes. So we've got infinitely many solutions. So sometimes you have to go a little further. I think on our first two examples, or maybe at least one of them, we saw what we wanted to see early. Here, it kind of delayed and made us wait a couple of extra minutes to see the 0 equals 0, but we got there. So infinite solutions on that one. Any questions there? So we'll do one more, and then I've got your worksheet for you today. I said this on Thursday, but why would you remember something that I said on Thursday? This worksheet's going to kind of be like what you've already been practicing. I assume you're already, of course, done with the others, ready for more, except this time there's going to be some of these infinite no solution ones sprinkled throughout. I believe it's half and half, but I'm not exactly sure. I made it long enough ago that I don't actually remember. So, but you'll see them sprinkled. So it won't be like this section is the weird ones and this section is the normal ones. They're just wherever they want to be. So for problem number 4, who do we want to eliminate? Yeah, I think that's a good choice again. And the thing is, like, less work is good. And the thing with the X's is if I just take the bottom ones, right, then I can just leave the top one alone, which is always nice. So we are going to take that top equation and copy it over. And then the new middle equation is negative 6 of those. Yeah, perfect. And then the bottom equation. Okay. So you can kind of see here, nothing is glaringly obvious at this point in time. Like we don't see, like we did in those other examples, how there's just going to be a big wall of elimination here. So we'll just kind of chip away at this one, kind of like we did the last one. And so what's our first row operation? I like that. Let's do row 1 plus row 2. If we do that, what do we get? Perfect. And then what's our next row operation? Good. And what do we get? Good. So you do see that again, because it's on this worksheet, not like this is a surprise. For this note sheet, these are all intended to be the weird new ones, right? So you do see that, whatever we set out to kill, if you don't see it yet, well, you'll see it soon, but you do see that. I hope that whether you set out to kill the y's or the z's, they're both going to go. So let's just take the top equation. Let's keep it as simple as we can, and let's multiply the top equation by 2. Nice and simple. And again, that accomplishes the objective of either killing the y's or the z's. It doesn't matter which one was your active target. So we get 4 of those y's plus 6 of those z's equals negative 60. And then the bottom equation, we didn't have to mess with it. And can you see the conclusion that we're going to draw here in a moment? What's it going to be? Right. Yeah. And it's when we add downwards here, the y's eliminate and the z's also happen to eliminate, and we fill a 0 there to give it substance. And 0 equals negative 105 is, of course, a lie. That is not a true statement. And since 0 can't equal negative 105, what do we say? There is no solution. Good. So that's the conclusion of the notes from Thursday. And then I'm going to hand out your work. I'll keep this paused in case you have any questions. All right. Cool. Okay, so you're going to tell me what you did so that I can follow along with you. Does that sound fair? Okay. So what did you do? I couldn't hear you because of noisy butts back here. Hey, keep it down. Zip it. I can't even hear Haley. What's the... You got rid of the t's. So did you divide or multiply? Okay, so you took the top equation and the bottom equation, presumably, and you multiplied them. What did you multiply by? I like it. Good job. So you made that one odd man negative. Good job. So you got 4 of those r's minus 10 s's minus 4 t's equals negative 32. Middle, you just copied down. And then bottom, you got 10 r's plus 12 t's or s's, excuse me, plus 4 t's. And that equals negative 2. We're doing okay? All right, so what was your first row operation? So R1 plus R2 should have gotten a cancel for the R's, a negative 8 for the S's, a cancel for the T's, and a negative 32. Is that correct? And then what else did you do? Say again? Okay. And what's nice is we could have stopped after that first one. Now we know that S is 4. Do you get that? A lot. So I guess assume based on that stare you just gave me that you didn't know that. But see, this equation right here yields a very useful piece of information. And that is if you divide both sides by negative 8, you now know that S is 4. But where people tend to panic is if they do spot that, then they just stop and don't know what to do. So by proceeding to do, you should keep going. That's what I was about to say, is if you do R, because if you just stop there, then you won't have anywhere to put that to get the other one. So that's why we should keep going. I just wanted to put a little side note here that this equation doesn't require, you don't have to do anything fancy. It's just a one variable. When you get the double kill like we got accidentally, then you can actually just solve one of them easy. So I'll show you what I mean here in a second if I lost you. So if we do R1 and R3, you should have gotten 14 R's, 2 S's, and then that's equal to negative 34, correct? So where people sometimes panic is, so let's say that I didn't have this here. I didn't write that S equals 4. It's really easy to look at this and say, I don't know what to do. But the reality of the situation, again, is that this equation just wants to be solved because it's got one variable. And we can solve any equation with one variable. Like, we're good to go. So if we know that S is 4, which you agree, we're okay with that, then we can start our answer down here and say, okay, so RST is the ordered triple, RST, so S is 4 is going to go right there. So if someone hadn't written the equation in the green box, then they would panic right now and say, I don't know what to do, because you need to have a place to feed your 4 into, and that's where that second purple equation, the one in the green box, comes in handy. So now I can take the number 4 and I can put it right there where that arrow is pointing. You see. So that equation now says 14 R's plus 8 equals negative 34. You still with me? You sure? Okay, and then we just get 14R equals negative 42 because we do what we've been doing for years, just solving equations. Subtract 8 from both sides, divide by 14, and you get R equals negative 3.
So. But I just need to, top inflation.
Which one? The top red one on the board?
They multiplied, row 1 minus row 3 by 4. And then, I did with the top. Negative 8 is negative 13. And I got negative. Oh, yes, that's it.
Yeah, that's fine. So what you did is you made it a trillion times harder than it had to be. So just let me say this first so you can feel good. What you did is not wrong at all. The fact that I mean, hearing you say that, you lost me for a second, and then I realized, oh snap, you just treated this purple system as a normal system and you multiplied and eliminated to kill the S's. I'm down with that now. But what you've, I think, failed to consider is that it could have been a lot easier for you. Not a lot. Maybe I shouldn't say that. It sounds like dramatic, but it would have been easier if you just went and cherry picked out this S real quick and then just plugged it back in here. That would have been a lot easier for you. But what you did was not wrong. But in the future, if the math gods just drop a free gift in your lap in the form of a one variable equation, take it, solve for that, and then just go find another 2-variable equation to plug it into. What on the scale, on the hard scale of 1 to 10, what you did is like a 3 and what I did is like a 2. So like it's not that big of a difference really.
It just would have been easier.
In hindsight, yeah, but what you did is not wrong. I want to make sure we're clear on that. I don't want you to think that it was. So you were just doing it the way you're used to doing it, but sometimes weird answers, like something falls into our lap and it disrupts like our normal process. So, but if you now know that R is negative 3, you can put that here. And now with those two numbers right there, you can plug them up in here anywhere you want to. Once you know 2, you go back and storm the original castle, right? So you good? Okay. Awesome. You're welcome.
Can you post the answers for this one?